All right, so these are some pictures of some very, very old compressors. So compressors are something that you see a lot of. Why? Because air is easily compressible, it's very easily moved. You don't have to have a giant tank to take it with you, right? Versus hydraulics, you have to have a pump, you have to have a tank, you have to have a system that brings it out to where you need it and back to where it comes from. You have to have a lot with hydraulics. They give you a lot of power for a little bit, but at the same time, you also have to worry about it getting loose. However, compressors are something that you regularly see on job sites. Why? Because pneumatics makes it work faster and better. It takes almost nothing for pneumatics to work. It takes a lot for hydraulics. That's why if it's a hydraulic machine, it is an isolated hydraulic machine. So what you're looking at with something like that would be a hydraulic press. That is a very simple form of a hydraulic system. It's not generally electric, but they can be. Just always depends on what you need, right? So we have several different types of compressors. You have reciprocating, you have the rotary screw, the sliding vane, the impeller, the liquid ring, the diaphragm, and centrifugal and axial flow. We'll talk a little bit about each of these. Okay. So motor displacement is the amount of fluid that moves through the device in one rotation. Okay. So inside all of these, you have something that's rotating. So the displacement is how much is it moving in that rotation. Okay. So positive displacement is a compressor in which a measured quantity of gas is entrapped in a space and then the space is reduced, increasing the pressure. So basically taking, let's say, your hands or a water bottle and creating that compression, right? We're reducing the space, so we're increasing the pressure. We measure displacement in cubic inches per revolution or centimeters per revolution over time. So one of the things you could probably see quite frequently in compressors is you do see single stages. These are ones that are the simplest. These don't have a tank typically, but they can. You have multi-stage compressors. These are the ones we typically think of when we think about a compressor. Intercooler is where you're cooling the air between the stages. Why would we want to do that? Why would we want to keep the air cool and not hot? Huh? All of those are good points, not quite what we're looking for. Okay, put it this way. Hot air expands, cold air contracts. So if you want higher pressure, what do you want to do? You want cold air. You want it all to want to come together. Does that make sense? We want to keep this stuff cool with intercoolers and aftercoolers so that we can get more compression for our buck. How about that? Yes, that is exactly right. The colder it's I don't know if that's Boyle's law or one of the other laws. I can't remember right now. But yeah, that's the basics of the laws of thermodynamics with fluids. It's why, well, we aren't going to get into that. So it's one of those things of I know where I can get off rambling sometimes, and I'm trying not to get off on that exit. We're going to keep going down the road. So the whole reason we have coolers on these is because A, you're right, we don't want it to get too hot. It can damage the internals of the mechanisms. We would like to preferably keep it cooler so that it is able to work more efficiently. The other reason we want to keep it cooler is because hot air expands, cold air contracts. If you have it cooler, you can force more together than if it's hot and everything's trying to bounce around out here, right? So that's kind of something to keep in mind. All right. So reciprocating compressors, these are the different ways that they can be. You got single acting, double acting, single stage, multi-stage. We're going to kind of talk about it. All right, so this should look rather familiar. How many of you know anything about the internal combustion engine? That kind of looks like it, right? Why? Because whenever you're dealing with an internal combustion engine, what are you dealing with? Let's say it's a four-cylinder. Hmm? Well, technically, the internal combustion engine works up with hydraulics and pneumatics. Gasoline will be your hydraulic fluid in that case, and the air it creates from the explosion of the gas would be your pneumatics. And I know a lot of y'all probably know more about the combustion engine than I ever will. I don't know how many of you actually open the hood of a car and go, okay, that's the engine, that's this. I'm one of those people that I can go, okay, there's the battery, there's where my washer fluid goes, there's where the oil goes. Yep, it's an engine. No, I think they've got that sealed away on my car, unless you put it in through the radiator. Yeah, my car is a 2018, and they start sealing that kind of stuff away from people so that they can't mess with it. They do not want you to mess with a lot of things these days. They want you to take it into the people at the dealership to let them make the money off of making it better for you. All right, so internal combustion engine kind of works the same way as this, but also quite differently. What it's showing you is it's pulling in air starting in this first one. It takes that air and pushes it out. And you have air being sucked into each of one of these and being compressed by the piston. So this is what they call a reciprocating compressor. This one would be multi-stage. Yeah. So this is a single acting, single stage compressor. What do you notice about it that would be different from the compressor you would find downstairs? There is no what? There's no tank. There is no tank. Also, this is your main mover. So do you think this thing's going to compress a lot of air very quickly, or is it going to run rather slow? It's going to be slow. But if you don't need a lot of air, would that work just fine? Let's say you're just a small shop, you don't require air, you've got mostly hydraulics. That would work just fine for keeping somewhere close by so that you can just kind of get air to whatever you've got to get it to and get things going. It's great to have fancy things, not always necessary. Let's see if this thing will pull up the video. There we go. Yep, this is one is a two-stroke. Well, you're not looking at an engine, you're looking at compressors. So we're in a engine. I believe your exhaust comes out up here. More than likely. Yep. Comes out in front of the piston where that's what is used to move the bike motor. This instead is a compressor. So what it's doing is it's compressing the air, and then once it's compressed the air, it feeds it to somewhere else. That's the only part you don't see on that. You don't see where it feeds the air, you're just seeing the fact that it's moving and able to move the air.
So that's like
Yeah, that would essentially be what that is. There's several different forms this can take. It'll, just like any components on any system, it always depends on what. What do you need, right? If you are a big place like Broza or someplace that uses a lot of pneumatics, do you need an inky dinky little compressor or do you need a monster compressor? You're going to have to get the big one and probably more than one, right? You're going to look for a really, really big compressor and you're going to look for something that is able to handle excessive use of pneumatics. What do you not want? Well, you don't want it undersized. For God's sakes, that would be awful, wouldn't it? Because if it's undersized, is it going to work? How long will it work? It'll work, but not for long. So you don't want it too small, but at the same time, you don't want it too big because what do these things run on? Electricity. If it's too small, it's running all the time because it's trying to constantly keep up with the air needs of your shop. If it's too big, then it's running all the time because you can't use it up fast enough to keep up with the yes, thank you. Because what happens over time with air is that it will escape from these compressors. They're not airtight. They are not meant to be airtight. Okay? So let's say I leave the compressor down there completely pressurized. I come back, I turn it off, and I come back tomorrow. It will be completely decompressed. Why? Because that's how they work. They are not meant to stay compressed forever. They decompress quite readily.
what? So if you left it on
Mm-hmm. But then you're not using the air, so what's the point? And then you're just messing around with your power bill. Then you also have other risks you run when you run a compressor continually, especially here in the South, especially in the summer. Because what's in the air in the summer? Humidity. Humidity and pollen take over our lives come spring, right? Anybody got allergies? We get the evil yellow death cloud that comes up every spring that says, "Wahahaha!" Everybody sneeze and cough. At which point all of us start retreating indoors and going, "Nope, I'm good. I don't want to write my name in the pollen on my car."
that goes away, once that goes away, a couple weeks later, boom, pollen. It's like they attract the pollen by putting the fertilizer out.
No, they cause the pollen by putting fertilizer out. But it's, hun, it's going to happen anyway. We have a lot of plant life Okay, we're gonna move on from that. Because I can't tell if you're actually asking a truly serious question or if you're messing around. All right. So this is a single acting, single stage, two piston compressor. So how would it work? Well, you got a crankshaft, right? So when you're moving one, yep.
So basically just, it's a 2-to-1.
Mm-hmm. All right. So this one is a double acting compressor cylinder. And this is why I say it works a lot like a engine. Because what is it doing? It's pulling in like you would pull gas into the chamber. But instead of a spark plug to light it off, what does it do? It just pushes it out. Because it doesn't need to light it. It's creating compression. It's not trying to change the state of compression from a liquid into a gas. So it's compressing on both sides at this point. What you do need to see is this. This is where your air inlet is. So whenever it's moving one way or the other, it's pulling air in one way, compressing and pushing it out the other. And you better believe all of those have check valves to make sure what?
It's doing the right thing.
It's going the right way, right? We don't want pressurized air pushing the air that's coming in back out the way it just came in. Does that make sense? So you better believe all of these have check valves on them to make sure that they're not moving the wrong way. And one of the things you should also see, and that's kind of what they're highlighting here, is that there's a cushion here. And why would we want an air cushion right there or a fluid cushion right there? Well, because you have metal on metal. What do we not ever want to do?
Spark.
Well, you definitely don't want sparks because you've created a fairly good environment for some amount of flammability. But the biggest thing is you don't want metal on metal because it just ends up putting a bunch of metal in your system. Mm-hmm. It's not hard to move metal in a system like this. So we're looking here at a single acting two-stage compressor. And you have what's called an intercooler right here. So intercoolers are cooling the air or fluid between the stages. Why would we want to do that? Well, because are you trying to break it down?
No, I was gonna crack it.
Yeah. Okay. As long as that's all you're trying to do.
Yeah, I'm not trying to kill myself.
Well, I mean,
Yeah, no,
your nuts doesn't move like that. All right, intercooler. So an intercooler is all about trying to keep your pressure up, but at the same time, you don't want overly hot anything and anything. Because overheating is a major problem in all machinery, right? What happens when a machine overheats? Hmm?
So you can break it down.
It breaks down. It breaks down very easily. Why? Well, because the machinery is just like everything else in the world. If it overheats, it's down. Generally, it shuts itself down before the overheating point where it's going to tear it up. Not always. What we try to do is make sure that it stays cooler, especially in high use compressors. Why? Because the more it runs, the hotter it's going to get. You've got friction at every stage of this. What does friction cause? Heat. And heat just keeps building and building and building until something's going to give. You give it a way to cool off, just like your engine and your motor oil. What's your radiator supposed to do? Keeps your engine cool because it cools what?
Oil.
It cools the oil. It quite literally is the thing that keeps the oil cool so that your engine does not overheat. And yes, I have picked up quite a bit of engine lore over the years that I've been doing this. So, any questions on this one? Oh, come on. Who in the world put that link right there? Oh, I can't get to that link. All right, so this one is what we typically see of a compressor. This one does have an intercooler. It's behind this grate right here. This is a two-stage compressor. And this is the tank everything's feeding into. Now, what is this little nozzle down here at the very bottom of the tank?
Relief valve?
It's not just a relief valve, it's a what? It's a relief valve for the water that builds up. Why? Well, this is a story I heard the other day. Apparently the compressor downstairs, they didn't run it for a little while. The next time they ran it, they realized they had a bunch of water in it because apparently several of the, not the pneumatic stuff itself, but the drains in the pneumatic systems, yeah, those will prove out water every time. We actually have systems over in the Ethel Hall building that we've had water in. The water all comes from a compressor. It's not coming from anything else in the line. It's coming from the compressors. So you have to make sure you're aware of where it is, what it's doing, and periodically you have to what? You have to drain it. It's internal. Okay, let me put it this way. All these things do is suck in air.
Oh, so humidity.
That's why humidity is our biggest enemy in this. Because humidity will kill everything, right? Well, this thing right here doesn't have a way of filtering that air out. It doesn't have a way of getting rid of the humidity. So what it does is just sucks in air. All it's doing is literally sitting in a room and going, sucking in all that air, bringing it down to these compressors right here, and it compresses that air. Well, two things happen when you do that. Number one, you will compress out the humidity. Number two, you give it the ability to create water. Why? Because you're bringing all these molecules that are just out here everywhere, and you're bringing them all closer together. The closer you bring it together, the more likely you are to form bonds between these. And what's one of the two? What are some of the most numerous elements that are in the air? Oxygen, hydrogen, helium, nitrogen.
Phosphorus?
Not really, unless you're at the 4th of July or New Year's. But those are the four main ones: hydrogen, oxygen, helium, and nitrogen. Those four are the main elements in the air. Two of those create water. So it's very easy to get water from air. Humidity is one of the biggest players down here in the south because it will suck in all the humid air and it brings it out. Kind of like, have you ever taken a towel full of water and just twisted it until it gets so tight that all the water rings out? That's what it's doing to the air. So,
So if you put like a wet towel in one of those, and like you hung it up, and like you put compressed air in it, would it just like the water on the ground, basically dry it off? It would compress it, or would it not?
I'm not quite sure where. Ask me that again at the end of class. Put it that way. I'm trying to imagine exactly the scenario you're talking about, and we need to focus on this. So periodically, here in the South especially, but pretty much anywhere in the world, you're going to end up with humidity in the air. No, there is no humidity like southern humidity whenever you walk outside and your gills have to grow in instantly. But with the kind of humidity we get in our summers, especially, you're gonna have to kind of keep an eye on the water valves and things like that because periodically, if you do not drain these tanks off, you do not ever want water in a system. If you start seeing water in your drains, you know what I'm talking about, right? On your units, you have that little clear bulb that's hanging on that air unit, yeah? That is your water capture system. If there is water or moisture in your system, that is what's supposed to catch it. When it starts filling up, that is when you, as maintenance tech, need to go check your compressor and possibly drain it. The other thing this acts as is as a pressure relief valve. Why? Because if I'm not there during, let's say, the next couple of days, if I take, we're coming up on Thanksgiving. A lot of places shut down for Thanksgiving and Black Friday. Yeah, that's most places in the area these days. But everybody shuts down for Thanksgiving and Black Friday. But I don't remember to turn this off, or I just don't bother turning it off. Why? Because hey, the company's got plenty of money, let's let it run through. If that pressure is not under use, we don't want pressure backing up into this. What would happen if pressure backs up into one of these tanks?
It'll eventually leak.
You create what's called a pressure bomb. Okay? And that's not a good thing. Ever. Have any of you ever seen what happens when dry ice is put with water inside a soda bottle and capped off? Yeah, think that, but about 100 times more energetic.
Wait, so you said it's not that it would leak out, right?
That's what the pressure relief valve is supposed to do.
So,
Is it puts all that extra pressure and it throws it out. So it can't overpressurize. If you decommission that pressure relief valve, yeah. Or that it's one of those things that nobody ever thinks they need to take maintenance on, kind of like the hot water heater. How many of y'all have ever done maintenance on a hot water heater? You? What kind of maintenance do you do? check valves periodically, things like that. How many people know that they're supposed to check a hot water heater over periodically? You know, at least once a year, you need to go down in the basement or into the closet, wherever the thing's hiding, and go, okay, are the valves still working? Are the pressure relief valves still working? Is everything still running okay? Because what is a hot water heater?
Gas heater.
It's a pressure valve. Or I mean, I'm sorry, it's a pressure vessel.
So they just to make it hot, they pressurize it?
No. If you decommission the safety features on these, it can build pressure inside. And it does not take much.
Yeah, they're pretty thin. You might feel them. They're thin now.
Yeah, watch Mythbusters one time. Their coolest experiment was the hot water heater rockets, whereby they decommissioned all the safety features on hot water heaters, heated them up to quite a good degree, and apparently that creates enough pressure that it pushes down against the bottom of the hot water heater, and then the next thing you know, top is going skyward. Seriously, cool.
We should do that. Yeah.
No, because that's kind of dangerous, and seriously, that's not something you want to do without having a lot of area where that thing's going to come down.
Well, yeah, we need to get like some land, and then you should make a mini version, and then you could like be like, that could be one of your things to get students to come to this college.
Yeah, except that that's not a.
Some parents would probably be like, no.
There's a lot of people that should be like, no, because that's not an experiment you want to do. That's a real life scenario that happens all too often. That's why you're supposed to do maintenance periodically on things. That's why you're supposed to do maintenance periodically on these kind of vessels, because if you don't make sure your safety valves are working periodically and they become, let's say, corroded, they can't open. Why? Because all the water inside this thing has gone to this bottom valve and rusted it shut. It can't do anything. Furthermore, over a couple of days or even a couple of weeks, water has come up to where that valve is. And I'm pretty sure that valve right there in the middle, that's the one that's giving you your shop air. You have not looked enough at the places where water would collect. So you're not aware that there's enough water in this tank that it is up to where you're going to be using it. So after a couple of days of sitting in water, what does the metal do? Rusts shut. This thing is still compressing. It's still trying to create pressure because it doesn't know what's going on in that tank. It has no connection to it. It's just a motor sitting on top that goes, okay, more pressure, more pressure, more pressure. The relief valves are done. You can't do anything about it. So thus, you've created what we like to call problem. You created a pressure issue. That is why periodically you have to do maintenance on all equipment. It's just like your engine. How often do you check your engine over? About every 3,000 miles? That's what you're supposed to do, right? Take it about every 3,000 to 5,000 miles to somebody to get the oil change. At which point they're looking at the engine over top to bottom and say, hey, dude, you have a belt that's going rough here. You might want to change that. Right? Or they sit there and go, hey, your brakes are kind of looking a little bad. They're looking a little thin. You might want to change them. You, on the other hand, have to be the technician that says, hey, boss, we need to take the compressor offline for about an hour or two, and we need to do some maintenance on it. Because your boss is going to be guaranteed to go, why? Well, because I'm seeing water in the lines, and we probably need to get that taken care of sooner rather than later. Before this thing starts throwing water around like putting a colander in a sink. Water goes everywhere. So this is a very common form of tank, but it's something that y'all really need to make sure whenever you're messing around with it to really check it over thoroughly. This is another compressor. Now, I'll go ahead and tell you now. Not all compressors are sold with a tank. And not all tanks are sold with a compressor. So if you're looking at a combo unit, you still need to make sure you get sized and everything else what you need for your system. Okay, you get 3-stage compressors. Okay, you can see where the air is moving between them. Here's one that's a multi-stage compressor, and it's got its own tank. Now, a tank can be oriented one of two ways. It can either be laid on its side like this, or it will be standing. Now, the only real difference between one and the other, the only really big major difference, is going to be where those relief valves are. Because the pressure is the pressure. You can't really change the pressure. But it's all about how much space can you take up. Okay? But I will say this, there's one shape most of them come in, and it is round. Why? Not so much. Anybody else? Actually, you're not far off. What about surface area? Volume? More volume? Okay. I'm terrible at doing this. Okay. So we've got a cylinder unit versus a square unit. Now then, air likes to act at what kind of angles, or pressure acts at what kind of angles to be pressurized? It likes to direct itself at right angles. Now, what's the difference between a cylinder and a square? There are no right angles in a cylinder, which means what? A square has corners, but that also means that the air is going to be pushing on those corners. And over time, what's it going to do? Create a weak spot. After you get a weak spot, what else do you get? A crack. A crack that leads to air escaping. You're going to have less pressure. Why? Because it is acting against those seams and it's able to push against the walls. What's easier to push, a ball or a wall? Mm-hmm. But can you get a lot of pressure on when you're trying to push a cylinder or something round? Is it easy to get a good grip? No. And push and get a high pressure? What about something square? You can go to the corners. That's why you just about always see a round container. It just lasts better, does better, holds the pressure better. It's just better. Do so. Because you have to consider what pressures you're putting on a lot of this. Now, whenever it comes to this, a lot of tanks, we'll not even talk about that. So, here's a good look at them. You got the verticals, you got the horizontals, you got single compressors that are their own unit. Again, generally you see a lot of those on work sites or temporary use. Okay. Any questions on that, guys? All right.
CFM is, what's CFM mean?
Cubic feet per minute. So sliding vanes. So I don't know how well y'all can see this picture, but if you look, there's this piece right here and a groove that it's sitting in. That means it has the ability to slide in and out as necessary as this spins. Okay? What that means is where the air has the inlet means that it's got the most capacity either here or in this section up here. But as this moves, what's it going to do? Create a smaller space as it moves. It slowly compresses until it gets to the outlet, and then all the air just goes, bye. Okay. It has a single stage pressure of up to 50 psi, two stage of 120, and is able to put out up to 4,000 cubic feet per minute. Not bad. Let's see if the video link works here. This one's kind of an interesting video. What I'm showing you is the outer unit. There's your filter. What's the filter do? Filter the air to keep all things like pollen and stuff out. This is just a very... They're not talking or doing anything. Let's just... No. So it's sucking air into this unit. Okay. Here's where it's starting to come into the compressor. It goes through the compressor's filter into the inlet. Okay. So as it goes through the compressor's inlet filter, it's going through the air intakes. Okay. Yep. Those are representatives of molecules. So it's going through the intake and it's pushed into and sucked into your air inlet. From there, here's the vanes. And as you watch, you can see them slide out. And each one's getting its allotment of the air molecules. And then you can see as it starts around, they have to start getting closer and closer and closer together, right? The air that's being coming in is cold. What is it whenever it goes out? Why? We're not actually creating friction by pushing it together, but the friction of what? The friction of the molecules against molecules is going to warm them up. So when they escape, they become very hot. That's why when you're dealing with any of this kind of things, you want to make sure that you've got some way to cool the air or that you are being very careful of that air because that air can become superheated. I don't know why anybody would put helium in their tires. It's kind of like putting helium in something like a football. It doesn't do anything for an advantage. You can't put enough helium or anything like that into a tire to get an advantage of it. The tire's too heavy. Mm-mm. Not more than maybe, yeah, it wouldn't be able to do much. We tend to think of helium as this thing that can lift. We have the cartoon version of something like Up, where we sit there and go, oh, helium can lift a house. No, you'd have to have a lot. That amount of balloons can barely lift a person. You're talking weather balloons that are made of latex and have to be really, really thick and tough in order to do that. There's a lot of problems with all that. Helium is not a miracle anything. It's just how to say this. Helium is number 2 on the atomic scale, right? Yeah. Hydrogen being the A, most combustible, and B, most unstable. That's why hydrogen likes to bond to everything. But helium is not got the capacity to lift really heavy things. Does that make sense? It takes a lot of it to do that, and a lot of very specialized equipment to get it to do that. You're more likely to helium's just not very good for a lot of things. All right, so rotary screw, you have a single stage ability of 50 psi, 2 of 150, 120 to 4,000 cubic feet per minute, depending upon the size. Give me my video links, jeez. Give me just a second, let me see if I can't get this video link to work. There we go. You kind of an idea how this works. Like this little video. So you've got literally the air pours through, and as it goes through, it tightens down each of these parts of the screws. I said this kind of gives you a better angle of it. The only problem is there's no such thing as a free lunch. Because I've thought about that issue before, and yes, it would be really, really cool to run a car on pneumatics or hydraulics, and nothing but. Couple problems. That's one problem. You'd have to have some way to run a generator. Oh, wait, we already have something. It's a combustion engine. 2, you would have to have some way to stick a motor in and make it actually work with a high enough speed capacity and with an ability to be variable speed. Does that make sense? Those are the 2 biggest things about that that would cause a problem for that particular run, because let's face it, this is not exactly a instinctual way to use these. Actually, the rotary screw is not a terrible thing to use, because this kind of design's actually been used to move fluids for a while. You have the Archimedes screw that was stuck in a tunnel, and as it spun, it was able to bring water from a low place to a high place. what it does is it spins, and as it spins, you can't really tell it very easily with these, but it gets narrower and narrower as it goes down one way. And so what that does is it causes the compression, and then when it comes out, it's compressed. So, all right, you got a lobe compressor. I don't think there's a video for this one. Oh. All right, you got the liquid ring. So all of this works on the principle of just trying to move things and finding ways to restrict the air or restrict the fluid as it moves. Okay. This one I always think of this kind of neat. It's called axial flow. It's kind of strange looking. And this is kind of a neat little animation on how it works. Okay, because you got some of these teeth that sit still and some that move. All right. Impeller, this is, how many of you know what a centrifuge is and what it does? Okay, how many of you like to watch the crime dramas like NCIS, Criminal Minds? Um, what is the one they just revived? Where they actually are in a crime lab and processing things. They just revived it. It's from Nevada. Oh, no, not NCIS. CSI. That old show. It's probably older than most of you. CSI is coming back, apparently. But a centrifuge, what it essentially does is, as it spins, it's trying to force things out to the side. This is how they separate blood parts. It's how they do a lot of things. They actually have centrifuge rides where you're strapped to the outer side of one of these rides, and then as it spins so hard that you're actually able to move up the wall because you're just about defy gravity for a few minutes. Why? Because the pressure of pushing you into that wall is so great, you can't actually force yourself down. I'm not the one that picked the video. I'm not the one that did the picture. I did not do the picture. I know. I did not pick the picture. I need to go find a different one, but I guess that's the closest the person that made this could find to a centrifuge. All right. So this one's a multi-stage I cannot even say that, centrifugal. Jesus. All right. So you can see the air coming in and being moved out. Another way you can think of a centrifuge, I don't know if y'all have ever seen this trick where somebody takes a bucket full of water and is able to swing it around without drenching themselves. That's using what? Centrifugal force. So what they're doing to compress that air is they're literally slinging around so hard that the pressure at the far side of this is greater than what's at the center of it. So that's what it's doing. Kind of an interesting concept. What? Me, I don't want to ever do it because I'm always sitting there going, if I don't swing this hard enough, I'm getting drenched. How did you do that? Just like take the cup and just like.
You just fill out the cup and you literally just go, and like it just stays just long enough to hold onto it. You let go, it's just gonna go everywhere.
All right, so this is a scroll compressor. You can quite literally see how this is working. So you got the cold air that comes in. I guess I'm pulling the air in here. And as it moves, I think they had that running the wrong way. I think it's supposed to run the other way. Somebody got their animation wrong. So honestly, what you would have is cold air coming in from the outside here, and as it moves, you would see it getting hotter and hotter until it gets in the center where it's really hot, but it's also the most compressed because it has the least amount of space to move. I'm gonna have to get a hold of these slides and change a few things. Okay. All right, so let's take a pause for a minute.